Things only get harder for the H2 rocket once it lifts off. Friction with the atmosphere subjects the nose to 300-degree temperatures. Without protection, cargo carried inside might just burn up, but an insulating material has got that problem covered, and it's painted on. This resin was developed based on the same concept. A thin coat keeps the elements out. When applied to a roof and walls, it provides a solution to summers that sometimes feel like 300 degrees. If the interior walls are painted too, the house will hold heat inside in winter. A demonstration tells all. These steel plates are heated. The gray one has regular paint, the white one the insulating resin. Ice doesn't last long on the regular paint, but even after a minute, the ice on the insulating resin holds its shape. This warehouse roof wears the resin. According to the owner, temperatures inside dropped as much as 18 degrees Celsius as a result.
Before the roof was painted with insulation, the heat was horrible. People couldn't work on the second floor. But after the resin was applied, it became very comfortable.
A factory in Osaka turns out this energy-saving elixir. What they're working with may look like ordinary paint. But in fact, it's a high-tech concoction mixed with inspiration and persistence. On J-Tech, the story of the company that examined and approached the challenges of spaceflight and then brought it down to Earth. Make way for J-Tech, the heart and soul of Japanese manufacturing. Here come your hosts, two of the most insulated figures in entertainment, Pak-kun, Mak-kun.
Hi.
Konnichiwa.
Mak-kun, are you sensitive to the heat and cold?
Yes, I get cold feet, I get hot flashes. I think it's menopause.
It might be menopause. Well, all of you out there who are bothered by extreme temperatures should watch very carefully. We have some interesting new technology for you. For example, take this. This is Japan's newest rocket, the H-2B.
Wow, the Japanese make everything so small.
Well, yes, they do, but this is not the real thing. This is just a model. It's 1/100th of the actual size. Now, this part of the rocket is called the fairing. It protects the satellite and other cargo during launch. Now, this is a piece of the real material from the H-2 rocket. And if you look closely, you'll notice that the surface is coated with a kind of resin. It's an insulation to protect the fairing from the heat during the launch.
Insulation on the outside?
That's right.
I thought insulation was the soft stuff in the walls.
Yes, you often find insulation inside the walls, but this is on the outside.
They should call it outsulation.
Well, I'll suggest the name change. Well, this outsulation, or insulation, is a very special type. It's a coating which is applied like a paint.
Really? So you could paint it on your walls?
That's right. Keep you warm in the winters and cool in the summers.
Or you could paint it on your windows?
That's right, although it'd sort of defeat the purpose of a window, but yes. In fact, you can use this space-age technology to insulate your home with just a very thin coat of paint.
Sound great! I'm going to get me some. But first, I've got to find out more.
Okay.
Oh, this is the place. Let's go inside. Nisshin Sangyo runs its Osaka plant with just 15 people. 社長さんでいらっしゃいますか。今日はよろしくお願いいたします。達次郎石子 is the top man. 早速なんですけども、こちらの断熱塗料について今日はいろいろ教えてください。
そうですね。
よろしくお願いします。
はい、わかりました。
はい。They say seeing is believing, but touch tells a lot too. First, a steel plate is heated. to 1200 degrees centigrade.
うわー、どんどん赤くなってくる。もうここが熱い。ここが熱い。ここが。ああ。うわ。
Next, another plate coated with the insulating resin.
いやいや、ここはもう赤くなってますよ。
ちょっと手を置いてみてください。
ちょっと、嘘。こっち。あ、怖い。あ、怖い。あ、大丈夫だ。あ、全然熱くない。あれ。すごい。熱くない。全然。
いいですか。
ここは熱いけど。
はい。
こちら、ここ広いですね。
This is where they make the resin.
ここで行われると。
そうなんです。
ということは、ここにもしかして、入ってる。
Inside the tank is water-soluble resin.
で、ここで何するんですか。
はい。それでですね、
はい。
この樹脂にですね、
はい。
断熱効果を持たすことのできる
はい
特殊なものをここで入れるんです。実は
はい。
Here it is.
これがちょっと変わった特殊なセラミックです。
セラミック。触ってもいいですか。
どうぞ触ってみてください。
はい。おお、すげえ、触ってないみたい。ほら。うわー、柔らかいっていうか。
これちょっと持ってみてください。
はい。軽っっていうか、何も入ってない。
ちょっと開けてみてください。
おお、入ってる。これ入ってるんだ。
そうなんですよ。
すごい。入ってる。すげえ。
It's a 2-liter bottle. If it were water, it would weigh 2 kilograms.
なんでこんな軽いんですか。
これはですね、
はい
ちょっと変わった構造のセラミックで、
はい。
中空ビーズと言いましてね、
中空ビーズ。
はい、ピンポン玉のように
はい。
丸い形をしてまして、その中が空気なんですよ。
Here's how they look under a microscope. The big ones are only 50 micrometers, and each one has air in it.
10ミクロンぐらい。
The size varies from about 10 to 50 micrometers. There are three types. One reflects infrared rays. Another radiates far infrared rays. And the nature of the third changes depending on the type of heat. All of these are mixed together.
ミックスして入れてあるんですよ。
Reflecting and radiating work together. The type that reflects infrared rays flashes back heat that hits the coated surface. The heat not reflected is transmitted to the coated object and radiated as far infrared rays. The idea to use different beads came about through cooperation with the Japan Aerospace Exploration Agency, the creator of the H2 rocket.
We develop about 50 to 60 patents each year. Altogether, we hold more than 800. We hope the private sector will create new businesses by making use of these patents. That's our goal.
JAXA shared some of its technology and know-how with the company. It showed that mixing differing components can make things better. President Ishiko took the hint. He mixed 3 types of beads of different sizes and capabilities.
すごいマスクしてますけど。
そうなんですよ。
危ないんですね。
今ね、セラミックがこう舞い散りますから。
The science is sound, but making it work depends on the skill of the employees.
ボンボン入ってる。これ全部入れるんだもんね。
そうなんですよ。
相当な量だよこれ。
The ratio of resin to ceramic is 4 to 6. The process requires constant monitoring. The speed of the propeller is continuously adjusted. Additives alter the thickness. The ceramic and resin are mixed for about 1 hour to make an even combination.
もっと近寄っても大丈夫ですか？もう
大丈夫ですよ。
はい。いやね、最初は
はい
この釜の
ええ
3分の1ぐらいしか入ってなかったんだけど、
はい
もうほら見て、もうだいたい8分目ぐらいまで。
はい。
うわ
もうこれこのどう言ったらいいでしょう。全体の 60% ぐらいはセラミックです。
ー。はい。
This insulating material is the result. The white color of the ceramic is the color of the coating. The ceramic is evenly distributed. The water evaporates, but the ceramic remains. The insulating layer is now in place on the surface. The Tokyo government and Tokyo Metropolitan University are seeing how this cuts carbon dioxide. One house has no insulating resin, the other has been coated.
These structures are like ordinary, identical homes. We built 2 of them.
The exterior wall of the non-coated house is 37 degrees centigrade.
はい、それでは断熱塗料を施したところ
The coated house is
33 degrees.
3度ですね。
That's a difference of almost 3.5 degrees. At that temperature outside, the inside stays cool without air conditioning.
エアコン全くかける必要ない。
No air conditioning means a 50% reduction in energy use.
ということですね。
This also would mean a 50% reduction of CO2 emissions.
入ります。
The resin is eco-friendly and easy on the eye. It can be mixed in 260 colors. Add blue, red, and black to the white ceramic and
下を向けて出てきた。出てきました。
brilliant sky blue paint.
出てきた出てきた。
It can be applied with a brush, a pad, or spray.
オーケー、ルート。
おお。
うまい。
High-tech insulating resin gets the job done.
社長もこんなぐらいでしょ？
いや、私より上手。
よかった。
Here's the cup I painted.
Oh, very nice, if artistically challenged. It's sort of rough to the touch. I guess it gets its texture from the ceramic beads in the coating. They account for 60% of it when it's applied, but 80% after it's dried. Now, you got to do a lot of experiments, but I'd sort of like to see the efficacy of this coating myself.
Okay, I'll fill 2 cups with boiling water.
Okay? Oh, it's steaming.
First, put your hand into the water.
No, but I will touch the cups. Oh, this one's pretty hot. It's uncomfortable to grab, but the one with the insulation coating on it is very cool. Well, it's warm to the touch. It's not actually hot. That's incredible.
Now, put your hand into the water.
No, you can't make me do that. But apparently this insulation works because the ceramic beads don't transfer heat.
That's what they say, but I don't get it.
Well, let me see if I can explain. Think about a sauna. A sauna can be up to 100 degrees Celsius inside. That's as hot as boiling water. But what would happen if you were to sit in a big pot of boiling water?
I'd make a lovely broth.
Yes, you might make a nice broth, but you'd also get burned. And that's because water transfers heat very well. The heat from the water enters your body, you get cooked. But that doesn't happen with air because heat doesn't transfer well through it, which is why you can sit quite comfortably in a 100-degree sauna.
And I look great in a towel.
I don't even want to think about that. Now, air is a great insulator, but this coating transfers just about as much heat as air, making it an excellent insulator as well.
They should make saunas out of that stuff.
I don't really know what you mean, but maybe. Now let's find out what led President Ishiko to invent this coating.
Tatsujiro Ishiko was born in 1954. While in college, he founded a company that developed and installed factory manufacturing lines. 21 years ago, in the summer, he reached a turning point. A factory where he installed manufacturing lines asked him to insulate the building against summer weather. However, the structure couldn't be easily cooled. It had a sheet steel roof and walls. Ordinary indoor insulation wouldn't work because the line was right next to the interior walls.
Something just happened that prevented me from turning down the request. Newspaper flyers were scattered all over a desk. I looked at the flyers. Black flyers, white flyers, they were strewn all over. First, I picked up the white flyer. I realized that the white ones weren't hot. I immediately placed the white flyer on top of the black ones. And after about 5 minutes, I touched the black paper that had been hot only a few minutes before. It wasn't hot anymore.
He thought if he painted the walls white, the same effect could be obtained in the factory. Ishiko gave it a try. After painting the roof and exterior walls, the room temperature dropped by 3 degrees Celsius. Ishiko realized he'd stumbled across a promising business opportunity. So he started conducting further research, mixing into resin a number of substances known to have insulating effects. He tried titanium white and mica, a substance that transfers little heat, even toilet paper cut into pieces. But he wasn't able to achieve the effect he was looking for. His mind went back to white paint, the source of his ideas, and he wondered if anything could exceed its heat reflection characteristics. Then he realized what such a substance might be.
When I was a kid, I often went out skiing. As it happened, there was a ski slope near the city where I grew up. The whitest thing that I have seen in all of my life is snow.
In the middle of winter, Ishiko got a sunburn while skiing. That's due as much to the snow as to the sunshine. Snow reflects 90% of sunlight, from ultraviolet to infrared.
I thought, if I could use a material like snow that's white to the human eye, but transparent under the microscope, maybe I could come up with something really great.
White but transparent, he found a material that satisfies that condition: perlite, a ceramic powder made of volcanic rock. Ishiko obtained some of the substance right away. He mixed it in the paint and tested it. Just as he expected, it reflected a great deal of heat. But the breakthrough that seemed so promising drizzled. Literally so. When applied to a wall or ceiling, it dripped. Ishiko thought he might be able to solve the problem by increasing the stickiness of the resin as much as paint would tolerate, but it still didn't work.
Because it dripped so much, I adjusted it so it wouldn't. But after time passed, It kept dripping and dripping. The weight of the ceramic powder was pulling it down.
A solution came by making hollow beads of the ceramic. Glass beads are used as reflective material for white road markings. Ishiko asked the manufacturer to make the same thing with ceramic. The turning point came 5 years after he repainted the factory, when he came up with an insulating resin suitable for sale. It didn't make much of a market impact at first, but revenue grew as word of mouth about the product expanded. The cooperation with JAXA began 4 years ago. The agency recognized the insulation technology Ishiko had developed on his own embodied the same concepts it used for its rockets.
I asked about the actual performance of his technology. He had already commercialized a product with technology that reached the level of our rocket insulating material. A few dozen micrometer hollow beads are used to create insulation. He'd already done it.
Just a year later, a new coating was developed that achieves high performance with 30% less thickness than conventional products. From houses to factories, it's been applied 5,000 times so far. A solution to overheating that is really cool.
One of the great things about this coating is that it's so easy to apply. It can be used in a variety of places. For example, they will paint an entire incinerator in a factory with it, so that if someone accidentally touches it, they don't get burned. Plus, when they go to fire it up again, the heat has been trapped inside, so it's more efficient.
They should put it on fry pans.
Well, now, fry pans are supposed to be hot. But that's not the only benefit. More recently, it's been working on the railroad.
All the long day.
Choo-choo.
An express train rolls cautiously along. Ice has been applied to the rails. The ice will help return them to the condition they were in before expanding in the summer. Steel rails swell in heat. At one site, they grew 10 centimeters for every 50 meters at 39.5 degrees. Left untreated, expanded rails are an invitation to trouble. A number of derailments around the world have been blamed on exactly that. The best solution for preventing rails from expanding is to keep them away from heat. Nissin Sangyo hasn't figured out a way to change the weather yet, but it is developing an insulation with a rail-laying company. For 3 years, they've been applying test samples of colors and components and observing the effects.
The rail without the coating and the one with the coating have a 5-degree difference in temperature. The differences range from about 5 to 7 degrees. This indicates that we have achieved a solution at some level.
Much of the work is done at Nissin Sangyo's Osaka factory. This lab is the front line of coating development. For rail coating, a material of high heat emission is added, along with the ceramic beads that are used in the company's other insulating resin.
We use powder from a stone called amphibole. This works really well in reducing heat and changing heat to far infrared rays. As a result, we can expect that it will decrease a structure's temperature when it's applied.
However, amphibole powder is heavier than hollow beads. When mixed in the resin, it drips. Unlike walls though, rails lay flat, so the developers thought, no problem. But mixing materials of different weights is a problem. The factory director, Hiromi Takao, tried to turn Ishiko's idea into a reality. Takao has been making coatings for 25 years. She adjusts the speed and the composition of additives.
Yes, this is amazing. We kept saying, really? Can we put some rails? Is it okay? I thought I add different things all the time. I'm interested in what happens, but I'm careful to avoid a mixture in which one part settles. On one hand, I always have fun. On the other hand, I get nervous.
A trial for rail coatings took place at the construction company. The researchers have measured changes of temperature on rails exposed to the sun outside. For this experiment, they use rails they put in a freezer earlier. This rail's temperature is -10 degrees. They raise it to 50 degrees with a heat lamp. A measuring tool reads temperature changes and calculates the amount of rail expansion in micrometers. That could be the measure of safety in operating a train. But one test is not enough. They need repeated results to prove reliability. 2.5 hours after the rail started to be heated, the measurements show the insulating resin is having an effect. Without the paint, a 50-centimeter long segment expands by 0.35 millimeters on average. That's about the same as the original steel. But the rail with the insulating resin has only grown 0.2 millimeters.
I think that the far infrared effect helps keep temperatures down. We have to keep experimenting, though, to find elements that can be changed for better ones, and those that don't need to be changed at all. We still have much more to discover.
Ishiko looks towards adapting the material to bridges and other steel structures. A substance that prevents metal from expanding may help his business grow.
So, Mak-kun, what did you learn from your immersion course in insulation?
That the right kind of insulation can cut energy cost and carbon dioxide emissions.
That's right. It can make things more comfortable for you, your wallet, and the planet. Plus, it might just help Japan reach its goal of reducing CO2 emissions by 25%.
Sound great. I'm going to get me some.
I thought you already went shopping. Anyway, before you go, let's find out the company president's motto.
This man's company makes products that are painted on for protection. So what would he do with ink?
はい、これを読んでいただいてですね、この文字に込められる意味を教えてください。
Do jobs you can be proud of for your children and your grandchildren. I think we should do good jobs, not just for ourselves, but also for those who follow us.
お父さん、おじいちゃん、立派な仕事してるねって思われるっていうのは大事ですよね。
Well, that's how I'd like to be regarded.
今日はどうもありがとうございました。ありがとうございます。
Insulating the environment for future generations. That's the legacy that Ishiko and his company intend to offer.